All right, so I'm going to make this bigger, and then we are going to go back to our notes from yesterday. So if you'll either pull out the sheet of paper you were working on yesterday or pull out the notes sheet that we were working with. Okay, so yesterday we started decay, and I'm going to talk back through that first problem. Let me let somebody in, and then we're going to go ahead and finish it out. And then if we have extra time, I would like to go through some of the around the world problems that you guys might have questions on. Okay, so for this first problem here, it asks us to graph this function. We know that this is a decay function because we have 1/3 as our base, and 1/3 is something smaller than 1. Okay. To find the y-intercept, remember we let x be 0, and then we solve for the y value. So we got 1 for this problem. The horizontal asymptote is going to be whatever is added onto the function. So there was nothing here, so we wrote in a +0, meaning our horizontal asymptote was y = 0. In our other functions, it's going to be identified here and there. So when we get to the horizontal asymptote piece there, you guys should know what to say. Okay, horizontal asymptotes also always have y equals as part of their equation. We had no x-intercept because the horizontal asymptote is something that our function gets infinitely close to but never touches or crosses. So we will never have a place where this function is 0. And then we created a table of values kind of centered around the y-intercept that gave us kind of what our function looked like. Okay, so are there questions on how we graphed that first decay function from yesterday? Okay, if there are no questions, I'm going to start calling on you guys. You guys are on a roll today, so hopefully we can keep it up. Jordan, Warren, I don't believe is here. Rashani, I saw you come in. Are you here?
Yes.
Perfect. So will you help me find the y-intercept for this function? So for the y-intercept, we switch our x to be 0. So what equation how am I going to rewrite this equation with a 0 in it instead? What would I write?
Y equal.
Mm-hmm. Good. What's next?
The 2.
Yeah. And then what?
1/3.
Yep. And what is that new exponent going to be? So instead of x, I'm going to use
1.
What is, yeah, 0, good. And then what's the last piece?
-1.
Perfect. So now, Rashani, do you remember what 1/3 to the 0 power is?
Can you say that again?
Yeah, do you remember what 1/3 to the 0 power is?
No.
So anything to the 0 power is the same value, and it's going to be 1. So we're going to replace that with a 1. And then 2 times 1 is 2. We're subtracting 1 from that to get our final answer as 1. So our y-intercept is going to be the point 0, 1. Okay. So this is our y-intercept. To find the y-intercept, we let x be 0. Thank you for helping, Rashani. It sounded like. What'd you say?
Can you repeat that part again?
Yeah.
You
So,
keep freezing, so I can barely hear you.
Oh, I'm sorry. Okay, so it says find the y-intercept. So we set x equal to 0 to find the y-intercept. So Rashani helped me rewrite this equation and we replace the x with a 0, then anything, no matter what the base is, if it has a power of 0, it will be 1. And then so we just substitute that 1 in for this piece. And then 2 times 1 was 2. We subtract 1 from that, just like our function, to get 1. This is our y value for our y-intercept. Does that help, Henry?
Yeah. Wait, so again, you said the 3. So the 1/3.
Uh-huh.
No.
That's to the 0 power. And
Oh,
anything.
so you multiply the 3 to 0, which would cancel it out.
Well, no, we don't multiply. This is an exponential function. Okay.
Mm-hmm.
But anything to the 0 power, so any value, you could pick any b value, to the 0 power is always going to be 1. So you can stick anything there. So any number to the 0 number, or to the 0 power is 1. Okay. All right, thank you. All right, so now let's see. Jonathan was not here. Navre, are you here now? So, Amar, are you there?
Yeah.
So we're looking for this horizontal asymptote. The horizontal asymptote is defined by this -1. So what am I going to write for this?
Can you say it again?
Yeah. So I'm looking for my horizontal asymptote. It's going to be in the form y equals some number. And the number comes from the end of the function. So what am I going to write for the horizontal asymptote for this graph?
0.
No. What number is at the end of this function?
1.
No.
Oh.
-1, right?
-1, yeah.
Yeah. So -1, and then I have to write it as an equation. So I need to have y equals in front of it. So I'm going to write y equals -1.
-1.
Yeah. Do you have questions about that?
No.
Okay. All right. So I forgot to go ahead and plot our points. So I'm going to go back and do that. So my y-intercept was at 0, 1, which is at this point right here. Okay. And my horizontal asymptote is at y equals -1, which is this horizontal line right here. Okay. It's kind of hard to see. Let me make it not dashed. Okay, so there's our horizontal asymptote. Then it wants us to find the x-intercept. So this is where we let y equals 0. Olivia was not here. Lisbeth, are you here?
Yes.
So I want to rewrite this function, and I want to have y as 0 instead. So what should I write? So I want this function, and I want the y to be 0 instead. How should I write that?
2.
Okay. And then what?
And 1.
Next.
No, it's like, is the, can I say the, I don't know, is the comma or I don't know. The,
Parenthesis.
yeah, parenthesis 1.
Mm-hmm.
And the better is like 3.
Yeah.
In
And then what's
and
the
-1.
Yeah, -1 at the end. What's the power of this?
X
Yeah, perfect. And then what are we setting it equal to? What number goes here?
Y.
But we're turning it into y is, what number is this?
Is a 0.
Yeah. Okay, so this says let y equal 0. So we're replacing the y with a 0, and we're trying to solve this. Okay, to solve this, we use Desmos. Okay, so I'm gonna make my screen a little smaller. I'm gonna open up my browser, make that a little smaller. And I'm gonna go to Desmos. I made this awesome thing for my IB seniors this morning, and then it didn't work on Desmos. So I was super disappointed. Okay, so to figure out what this is, to figure out what x is equal to, we're gonna stick the pieces into Desmos. So I'm gonna stick the left side in as y equals 0. Oops. And I'm going to stick the right side in as 2 times 1 over 3 to the x power minus 1. And I want to look at where the red and the blue cross. They cross right here. So my x is going to be 0.63. Okay. So my x-intercept is going to be at 0.63, comma 0. This x value came from here. And I'm going to go ahead and plot that on my graph.
I'm sorry because my internet is not working.
Oh, you're okay, Lisbeth. I'm sorry. You did a great job. I didn't need you to do more. It's okay.
Okay.
Thank you. Okay, so we have graphed it and found the intersection of those two lines. Okay, and so we want to plot that. So 0.63 is a little over a half, so it's going to go somewhere there. All right, and then I want to come up with a table of values for this. So I want some negative numbers and I want some positive numbers. So maybe I'm going to do -3. And -1, and then maybe +1 and +3. And I'm going to sub each of these x's into this function to figure out what I should get. So let's see. So we can do this in our calculator. So I'm going to take 2 and multiply that by 1/3. Raise it to the -3 power. Oh, my battery almost died. Okay, so 2 1/3 to the -3 power. Okay, and I'll see what that is, and then I subtract 1. So that's a pretty big value. We get 53. Oops, I wrote 56 for some reason. I don't know why. There wasn't even a 6 anywhere on this page. So 53. That's huge. So we won't be able to fit that on here. So I'm going to do this again, but with the -1. And then subtract 1. Oops. And I get 5. That's much more reasonable to plot on our graph. And then 2 times 1/3 to the first power. It's still just going to be 2/3, and then we're going to subtract 1, and that should give us -1/3. And then if we cube this, so 2 times 1/3 to the third power minus 1 is going to be close to -1, so -0.93. Okay, so -3, -1, 2, 3 is like way up here. So the next thing I'm going to plot is -1, and it's at 1, 2, 3, 4, 5. I'm going to plot +1 at -1/3.